couple of things we need to do. How many of you have looked at the 312 homework? Wait, looked at it yet? Not yet? That's all right. We can do tomorrow. But why don't you get it out? Because there are a couple of problems that I want to talk about here. All right, so we're looking at our 312 homework, and we're going to look at problem number 4. Problem 4, 5, and 6 are all basically the same kind of problem. So I'll just pick 4. It says find the cosine of 11 pi over 12. Now, I want you to think about your unit circle. What angles are on your unit circle? Pi over 6, pi over 4, and pi over 3, right? And then they're corresponding, like, 7 pi over 6 and 4 pi over 3 and all that. The pi over 3s, pi over 6s, and pi over 4s are the angles that you've got. You do not have the pi over 12s. Okay? So here's what I want you to do. I want you to think about all of your unit circle angles. Go all the way around the circle. All the way around if you want to. Find 2 of them that will either add or subtract to 11 pi over 12. Now think about that. Probably you're going to use maybe a pi over 3 and a pi over 4 because their common denominator will be 12. So see if you can think of a couple. And there are lots of possibilities. And you can either add or subtract. Any of your unit circle angles, think of 2, there's 2, that will add or subtract to 11 twelfths. Come on now, you're smart people, you can figure this out. You want 2 fractions that add up to 11 twelfths. So Patrick says 3 pi over 4 and 1/6. All right, let's check it out and see. If I were going to add these 2 together, that's 3/4 and 1/6. My common denominator could be 12. And 9 and 2 add up to 11. How about that? Now, there are other combinations. This is a find one. Your job is find one. It can be add or subtract. Okay, got it? All right. Now, this is a cosine of an angle plus an angle. You got a formula for that. What is our identity for the cosine of alpha plus beta? Angle plus angle. What does it say? Cosine of the first, cosine of the second, minus the sine of the first, sine of the second. Remember, these have to be memorized. Okay? It's not that hard, but you're going to have to make the time to do it. Something to do on an airplane, something to do on the beach, something to do in a car, or whatever. In your backyard, I don't care, whatever you're doing next week, let's get these things memorized. All right, now, let's plug them in. Do we know the cosine of 3 pi over 2? Heck yeah, we do. Yeah, we do. It's what? Negative root 2 over 2. Negative log of 2. What's the sine of 3 pi over 4? Positive root 2 over 2? Now what about the pi over 6's? Cosine is root 3 over 2, good, and the sine is 1/2. Is that okay? So now, these are being multiplied, so that's negative root 6 over 4. These are being multiplied, so that's root 2 over 4. These do not add because they're not like radicands, but since they have the same denominator, we typically write them as one fraction. Negative root 6 minus root 2 over 4. Now, remember when I said there were other combinations besides this one? The answer will be the same, no matter what. Some of this will look a little different depending on what angles you were using, but that's the answer to the question, no matter what. How you say it. Okay? So, what are you going to do with problem 5? We're not going to do it right now. But what are you going to do with it? Find two angles from your unit circle that either add or subtract. This time to 7/12, right? And then you'll use, it's a sine problem, so you'll use your sine formula. Now, what are you going to do about number 6? Caitlin?
The cosine of 12 over 13.
Exactly. No. Never reciprocal the angle, Caitlin. Never reciprocal the angle. You are right, though. I do not have a formula for secant, so I am going to find the cosine of 13 pi over 12. Okay? Just like I found the cosine of 11 pi over 12 here. And then once I get that all worked out, like once I get to here, then I will flip it. Remember, we flip the cosine. We don't flip the angle. So the angle is going to stay 13 pi over 12. You're going to go through and do exactly what we did here. But then flip this. Okay? All right. Let's take a look at one more, number 7. So don't be working on these now. I want you focusing on number 7. You can go back and look on those other ones another time. So let's see if we can figure out problem number 7. Alpha and beta are in standard position and both lie in the interval from pi to 3 pi over 2. What does that mean? Pi to 3 pi over 2. They're in the third quadrant. So alpha's in the third quadrant, beta's in the third quadrant. The cosine of alpha is negative 5/13. Is that okay? Adjacent over hypotenuse, x over r. And the sine of beta is negative 2/3. Find the sine of alpha minus beta. Now, is everybody okay with my setup here? Good? All right. I have a formula for this. What is my formula for the sine of alpha minus beta? Sine alpha, cosine beta, minus cosine alpha, sine beta. Guys, I'm right on the sheet. alpha and I don't have it. What am I gonna have to do here to figure out the sine of alpha? Find the third side, and how will I do that? Pythagorean. So this one's gonna work out nicely. 35 squared plus x squared is 13 squared. So I think this is negative 12. Make sure you mark it negative. Remember what quadrant you're in, right? So now I know the sine of alpha is negative 12/13. Well, shoot. I need the cosine of beta, and I don't have it either. So I'll do the same thing. This one isn't going to be as nice. What is that side going to be? Negative 5. 9 minus 4. So the cosine is negative root 5 over 3. Adjacent over hypotenuse. X over r. Cosine alpha. Got it. Negative 5/13. Sine beta. Negative 2/5. This is really like the last problem we did, except in the last problem we were using unit circle angles. Here, they're made up angles. The idea is the same. Alright, so what have we got here? Looks like 12 root 5 over 39. I know that reduces, but don't, because I'm going to keep a common denominator here. So 12 root 5 over 39. Minus 10 over 39. A lot of negatives going on there, but I think it's minus. So 12 root 5 minus 10 all over 39. How does that look to you? Okay. Now, one more comment, and then we're going to move away from the homework. If this problem, instead of being sine alpha minus beta, if it would have been cosecant alpha minus beta, I would have done exactly this very same work, but then at the end, I would take my answer and flip it over. We flip the sign. So find the sign and then take the reciprocal. Everybody got it? Okay. All right, so now, go ahead and get your notes out now. And we are going to do the back page 7. Some of the stuff I get from Calcutta, and she's using degrees. We do not do degrees in AP Pre-Calculus, but let's go ahead and do the problem in degrees because it's going to be exactly the same as if we did it in radius. The numbers will be the same. So what do you want to do here? Let's find the exact value. Can you write, we're on the back of page 7, can you write 75 as either the sum or the difference of two unit circle angles? 30 and 45. Remember, 30 is pi over 6, and 45 is pi over 4. So if we were doing this in radians, we would be doing pi over 6 and pi over 4, but we're going to do 30 plus 45. So this is pi over 6, this is pi over 4. Alright, so step 1. Figure out if the angle you're asked to do is not on the unit circle, then figure out how to add or subtract to get it. Alright? What's our formula? It's the sine of an angle plus an angle. Sine the first, yep,
Cosine the second.
yep,
Plus.
yep,
Sine of the second. Cosine of the second.
yep. And these can be in either order. But that's fine. Here we go. These are all quadrant ones, so no negatives to worry about. Sine 30, sine pi over 6 is 1/2, and cosine is root 3 over 2. 45, sine and cosine match, and the root 2. How's that look to you, root 2 plus root 6? Looks a lot like the answer we got to that other one we did, but that's always gonna happen, because you're always gonna be using the same numbers, root 3 over 2, 1/2, or 2 over 2, so you're gonna get the same combinations. All right, now you do with your partner cosine 255. Cosine 255. This is 17 pi over 12, if you want to do it in terms of radians. See if you can figure it out. Anybody find a combination? There's lots. Anybody find any of them, Sam?
Can you do 210 and 45?
You absolutely can. That would be 7 pi over 6 and pi over 4. Or 210 and 45 if you're doing it with degrees. What's our formula for the cosine of an angle plus an angle? Cosine of the first, cosine of the second, minus sine of the first, sine of the second. Now what makes this one a little bit trickier than the last one is that some of your values are going to be negative. Because 210 degrees, if you're looking at degrees, or 7 pi over 6 is in quadrant 3. And so won't the cosine and the sine both be negative down there? So the cosine of 7 pi over 6 is negative 3 over 2. This one's negative 1/2. These guys are root 2 over 2. How's that work, everybody? You okay with that? All right. The next problem asks you to kind of derive your double angle identities. So let's look at sine first. Sine 2 theta. Would you agree that that's really just the same as theta plus theta? So alpha and beta? What does our formula say? Well, I have a formula for that, but I'm writing it. So this would be sine of the first, cosine of the second, plus cosine of the first, sine of the second. And what do you notice about those two pieces? They're the same. So I have one of them and one of them, so that is two of them. And that is what you memorize. But that's where it came from. It came from your alpha plus beta identity. And we do the same thing with cosine. Isn't cosine 2 theta the same as the cosine of theta plus theta? What's that formula say? You believe cosine alpha plus beta is cosine first, cosine second, minus sine first, sine second? And isn't that what we're memorizing for the cosine of 2 theta? Okay, so that's what number 3 is about. These are called your double angle identities. You need to know. All right, one more. Sine 2x minus sine x equals equal. I don't think we've done something like this. So do you have an idea? There's a very definite way you have to do it. Does anybody see it? Now, that is a very common thought, but SIN by itself doesn't exist. So you can't factor out an SIN. That doesn't work. Now, you can take out a sin x, but this isn't sin x, this is sin something else. But you're on the right track. You're on the right track. The problem isn't doable with a 2x and an x in it. That's like two separate variables. So we have to fix that. How can we fix that? I just erased it. What's sine 2x? 2 sine cosine. So what if I change this into 2 sine cosine? Then, William, I can factor out a sin x. And that will leave me with 2 cosine minus 1. something equals 0, and some of us mess that up. I encourage you, pop your little unit circle down on the paper. Sign is Y. Where is Y 0? At 0, at pi, and at 2 pi, right? So this is 0, pi, and 2 pi, because 2 pi is included in these instructions. Now, where is the cosine 1/2? Here or here, right? What angle is that? The cosine is 1/2. That's pi over 3. So we have pi over 3, and then the fourth quadrant pi over 3, which is 5 pi over 3. How are we? You okay with that? All right. The next page is one of these circuit trainings. We did one before. So you start with problem number 1. You figure out the answer. And then you go through and find that answer in another box, and that becomes problem number 2. Remember doing that before? All right, let's go. Let's see how far we can get. You and your partner. We'll do about 5, and then we'll touch base and make sure we're on the right track. So do problem number 1. Find the answer. Then locate that answer, and that becomes problem number 2. Okay, number one, did you get -1 for your answer? For number one? All we're doing is plugging in 3 pi over 2. Oh, wait. So we're finding the tangent of 3 pi over 4, which is -1. All right, so then that took us to the problem that says the tangent function is always doing what? Think about what a tangent looks like. It's always increasing. Always. Cotangent, on the other hand, is always decreasing. Part of it's concave down, part of it's concave up, but it's always increasing. All right, so that took us to the one that says, as the x values go. All right, so here's cosine. And wherever the cosine has a relative maximum, what happens to the secant? Remember, the secant looks like this. So if the cosine has a maximum, the secant actually has a minimum. All right. So that took us then to, what is the period of this? What is the period of that guy? Well, I don't find the period of tangent is pi, but not when it's got a coefficient. So it's pi divided by pi over 4. Isn't that just 4? Everybody good with that? And that took us to the one that says this. Now, this is no calculator. You need to know, oh, there's so much to remember. You need to know the angle whose tangent is a negative number. Remember that the inverse tangent is a right side function. So whatever the answer to this question is, it's coming from that part of the circle. Wouldn't it have to be down here? If it's negative? If it's -1, then don't x and y have to match? And what kind of angle do they match at? Pi over 4. So the answer is negative pi over 4. No other way to write that. It must be written as negative pi over 4. So what is that? That takes us to exactly the same kind of problem, but this time it's a sine. The angle whose sine is 1/2. Again, it's a right side function, sine and tangent. 1/2. What'd you say? I hope you said pi over 6. Very good. Yep. That's the answer, pi over 6. problem, which is the same idea, but, different. It took us to the problem that says the cosine is negative root 3 over 2. What kind of angles have a cosine of root 3 over 2? Pi over 6s? And since a negative cosine, it would have to be the pi over 6s over here, which would be what? 5 pi over 6 and 7 pi over 6. And all of the coterminals. This problem says find an angle. This problem says find an angle. But that notation limits you. This does not. This says find one. So there they are. All right, I don't want to get too far ahead of you. I know where you are. Are you where I am? That was last one you guys did? All right, so let's pause for a second. Let's give you a few more minutes to work through a few more. So for me, this was my number 7. And then it took me to the one that has this written down. All right, so let's keep going, see if we can get a few more done. cosine over sine, x over y. So you had to skip the tangent step if you want to flip it. It doesn't work.
Like, wait, like these two? Yeah, 7 and 8. So, because this could be anything. It's like, so it has to be like that. Yeah, but this could also be. Okay. No, isn't it? Yeah. This starts off. No, but there's But doesn't it start on the next? I know. Yeah, there's a 0 on there. I didn't think it. Oh,
Let's see if we can get this next set talked about. I heard up here, I'm listening to the conversation up here, and Kyle said, this is exactly the same. One of the drawings said, this is exactly the same as the problem we just did, except it's restricted because of the notation. So the answer to the last one was 5 pi over 6, 7 pi over 6, and all the coterminals. This one is just 5 pi over 6. That is the one and only answer. And that brings us to this, which, what angles have a tangent of 1? Pi over 4, and all of the adding all the pi's after that. So you could add pi and get 5 pi over 4, add another pi and get 9 pi over 4, and so on. Okay, so that brings us to this one. What is the angle, start here, what is the angle whose sine is negative 1/2? Remember, it's a right side function. So, negative pi over 6. So this says find the cotangent of negative pi over 6, which would be x over y. So root 3 over 2 over negative 1/2. Did you get negative root 3 for that one? And then that brings us to this one, which is a little solve. So we'll bring solve. From 0 to 2 pi, where is the sine negative 1/2? Negative 1/2. 7 pi over 6 and 11 pi over 6. And we're going to stop there because of this. And then that brings us to the last one that we have time to do here. Where is the first, how does it worded? Where is the first vertical asymptote to the right of the origin? Here's the origin. Where's this asymptote? Pi over 2. hopefully we'll have a little time to finish that up tomorrow. I'm also open to answering that homework is a little tricky, a couple of places. So if you want to get a head start on that